Goodi Sign is a document signing web application connecting Google Workspace organizations with Visma Sign. The application operates entirely through its verified canonical domain, vismasign.goodi.fi. Before any sign-in occurs, the public landing page explicitly enumerates every Google permission requested by the platform. This diagram shows a strict, impenetrable barrier between user data and AI models. It illustrates adherence to the Google API Services user data policy, specifically the limited use mandate. No Google Workspace data, whether raw, aggregated, anonymized, or derived, enters any generalized machine learning pipeline. Transparency and strict data boundary logic are structurally built into the user's initial touchpoint before any OAuth token exchange takes place. When a user initiates the sign-in flow, they are securely redirected to Google's authentication servers. The resulting OAuth consent screen correctly displays our verified application name, Goodi Sign, linked directly to our client ID. We request 3 specific identity scopes: first, the Open ID, then the profile, and finally, the email. These scopes provide the stable subject ID needed to authenticate the user session. We do not request broader architectural access. Invasive scopes are completely omitted from the consent screen. The application establishes secure, verified user sessions while strictly maintaining a minimal footprint identity model. Once authenticated, the primary user interaction is selecting an internal Google Workspace document to send for external electronic signing. We invoke the Google Picker API as the secure, Google-hosted intermediary for this file selection. Here, a user's entire Google Drive is locked behind a heavy border. We use the drive.file scope, ensuring the application remains blind to the broader Drive ecosystem. It receives an access token only for the single file physically clicked by the user. Selected Google Docs, Sheets, or Slides are then temporarily converted into standardized PDFs by our back-end processing pipeline. This payload transfers securely from Google Cloud's Europe North 1 region to the Visma Sign API. Application ingress relies entirely on explicit manual authorization for each individual file. Next, the user must designate signers to generate the Visma Sign types. A real-time API request pulls autocomplete suggestions directly from their authenticated Google contacts to ensure accuracy. This visualization shows query packets bouncing between our application and Google contacts. This contact payload exists only ephemerally in memory. 0 contact data is written to the database, modified, or exported to third-party marketing engines. API read access operates purely as a transient interface enhancement, leaving all third-party personal data securely untouched. Users track document progress via an internal dashboard that polls for status updates as signatures transition from pending to signed. When a document is fully executed, the user can manually trigger the Save to Google Drive command. This action re-engages the drive.file scope, transitioning its function from read-only ingress to write-back execution. This write operation is strictly localized. The application deposits the final PDF only into the specific directory chosen by the user. The completed payload, containing the cryptographic signature, is transferred securely back into the Google ecosystem. The data lifecycle completes a closed loop, maintaining the principle of least privilege during both ingress and egress. Goodi Sign also provides an alternative integration vector, a Google Workspace add-on running natively right within the editor sidebar. Upon initialization, the add-on instantly identifies the authenticated session using the userinfo.email scope. This diagram shows how contextual editor scopes operate. The scanning beam reads only the active document tab, governed by current-only scopes. These programmatically restrict the add-on to reading only the file ID and title of that focus tab. The add-on triggers the drive.file scope to export the active file as a PDF. Finally, the workspace.link preview scope specifically enables the generation of smart chip status cards whenever Visma Sign URLs are pasted. The add-on architecture successfully maps the strict user intent isolation protocols of the web application directly onto the Google editor surface. All 11 requested scopes across the web application and the add-on correspond strictly to explicit user-triggered features. All infrastructure, including Firestore databases, cloud functions, and temporary metadata, is strictly confined to the Google Cloud Europe North 1 region in Finland. Complete compliance documentation is available on our verified canonical domain for final audit. Goodi Sign operates as a highly restricted, user-governed utility that meets and exceeds the requirements of the Google API Services User Data Policy.